Howdy, everyone. We're going to go through the lesson 4 of graphing quadratics today, and this is looking at the quadratic formula. There is a derivation that you can use to eventually solve deductively for the quadratic formula. However, what I'm going to just do is I'm just going to attach a video from Khan Academy. They go through the same derivation and they show how you can eventually end up with the quadratic formula. But for us, the only important thing for us to know is what the quadratic formula is. The quadratic formula has a fun little song, and when we are solving for the quadratic formula, we are always going to be solving for some x value. And when you find that x value, you can then take it and plug it back into the original equation and solve for a corresponding y value. But the little song that goes with it is negative b plus or minus square root of b squared minus 4ac all over 2a. And I'm going to fix that little line there because I missed it. So that is the quadratic formula. And where those values come from is when we're thinking about an equation in standard form. Usually it's y is equal to ax squared plus bx plus c. And so where those values are all coming from is the values of b are coming from this bx. Values of a are coming from ax squared here, the a value, and then the value of c comes from this little last c here. And so, kind of the key rules to using the quadratic formula, the restrictions that we actually have is we need to make sure that all terms or all numbers are on the same side of the equation. In essence, what we want to solve for with this quadratic formula is we want to solve for when y is equal to 0. And we want to solve for the corresponding x point. And so, in order to do that, we need everything to be on the same side. And we can then determine values a, b, and c, plug them into a formula, and solve by simplifying. And we'll talk about this taking the two roots separately point, but this is crucial only because of this plus or minus value, meaning that we are going to have two potential answers for the quadratic formula. Now, when would you want to use the quadratic formula? You would want to use it in scenarios where it would otherwise be very, very difficult to factor it. If we look at this first equation here, we could, I'm going to rewrite it here, we could try to get all of our variables on the same side. We would subtract 2 from both sides, and we'd end up with 3x squared plus 5x minus 2 is equal to 0. I said last time that having numbers in front of my x squared, I don't love that. So let's try dividing by 3, I guess. Divide both sides. Divide both sides by 3. And when we do that, we end up with x squared plus 5 thirds x minus 2 thirds is equal to 0. I have no desire to factor that, and I have no desire to learn how to factor that. So instead, what I'm going to do is I'm just going to say, well, I originally had this as my standard form. I originally had this. And this 3x squared plus 5x minus 2, all my terms are on one side. Instead of trying to factor it, what if I just plug them in instead of into the quadratic formula? What if I just did that instead? So we have 3x squared plus 5x minus 2 is equal to 0. So then the next thing that we are told, we got all of our terms on the same side. We want to determine the values of a, b, and c. 3 is a, 5 is b, and 2 is c. So we have all of our different values there. Solve by simplifying, taking the two roots separately. So what we want to do is we want to say x is equal to negative b, so negative 5 plus or minus the square root of 5 squared minus 4 times 3 times 2. And that'll all be over 2 times 3. Now, why we want to take the two roots separately is we want to eventually have a 5 plus the square root of this and a 5 minus the square root of this. So let's figure out what is actually under that square root. 5 squared is 25 minus 12 times 2 is 24. So we would end up having two different solutions. And one of our solutions would be x is equal to negative 5 plus the square root of 1 over 2 times 3. And the other option would be over here. It would be x is equal to negative 5 minus the square root of 1 all over 2 times 3. And we would solve for both of those cases. The square root of 1 is simply 1. So negative 5 plus 1, that would give us a negative 4. And we would end up with x is equal to negative 4 over 6. Or x is equal to negative 2 thirds would be our two solutions. Or one of our solutions, excuse me. X is equal to negative 2 thirds. And this other one here, we'd end up with negative 5 minus 1. It would give us negative 6. And so we'd end up with x is equal to 6 divided by 6, or negative 6 divided by 6. We'd end up with x is equal to negative 1. And so right here, we have our two answers. We have this answer and we have this answer here. And that's how we could use the quadratic formula is we would want to write our solution set in curly brackets. And so to do so, you'd want to say that x is equal to curly brackets, -2/3 or -1. And that would be our solution set for that particular answer there. So using the quadratic formula is really, really straightforward. In terms of everything that we're solving for, using this quadratic formula is quite simple. Where it gets a little interesting, we're going to do this first example here, and then I'm going to give you the chance to do these other two examples. Where it gets interesting is if we have an example like this. We have 6x squared minus 3x is equal to 7x. I'm going to subtract 7x from both sides. And so when I do that, I have -3 minus 7x, and I'll have 10x is equal to 0. So in this case, I can right away see I actually do not have a value for c. I have an a and a b, but I don't have a c. Now, I'm going to make my life a little bit simpler, and I'm going to work with smaller numbers. I'm going to divide this entire thing by 2, and then I'm also going to divide 0 by 2, which we know is just 0. So then I have 3x squared minus 5x is equal to 0. Then what I can do is I can plug this into the quadratic formula. So -b plus or minus square root of b squared minus 4ac all over 2a negative, and then I have a -5 for my b, plus or minus the square root of -5 squared minus 4 times a times c. Well, a in this case is 6, 4 times 6. C is 0, so that makes that calculation a little bit easier. All over 2 times 6. Okay, and then we would end up with two different directions that we could take this. We'd end up with x is equal to 5, so a negative, negative, that would turn that into a positive. 5 plus square root of 25 minus 4 times 6 is 24. So that one's a nice, easy solution. And that's going to be divided by 12. And then the other one that we have is x is equal to 5 minus square root of 25 minus 24. And that'll all be over 12, like such. And so the two solution sets that we'll have then is we'll have 5 plus, this is 1, so 6 over 12, which is equal to a half. And then the other solution set that we would have is 4 over 12, which is equal to 1/3. So our solution set would be that x can be equal to 1/2 or 1/3. So that's how you use the quadratic formula. Really straightforward. You just take the numbers, chuck it into the equation. Again, the key steps that we need to take are making sure that all terms are on the same side, determining the values for a, b, and c, plugging them into the formula, and then this arrowed step taking two different directions, going plus and going minus the square root symbol. I usually do my plus on the left, my minus on the right, just to keep things consistent and ensure that I'm always following the correct steps. So that's how you use the quadratic formula to solve for equations that are really tough to factor. Hopefully you enjoyed. Let me know if you have any questions.